So I've been finding, lying around everywhere, a lot of old, ancient IDE hard drives. And, of course, I decided to dismantle them for the parts within. First, I took the platters, and now I have a very nice bag of very shiny hard drive platters that I polished and have in here so I don't get fingerprints on them that I might do something with eventually. And this one's, I didn't clean this one up, but this one's from another little laptop hard drive that died. So, whatever, one of them was like an 80 gig IDE hard drive, the other was like 250 gig, and I can't do anything with them. I see no reason to actually try to use them. I don't think they went bad, but there's nothing for me to try to do with them except for take them apart and have fun with them. And in this case, that fun involves trying to make one of them into a magnetic stirrer for when I'm doing circuit board etching. Having a little magnetic stir bar in there, kind of agitating the etchant solution or the developer solution, would be super helpful. And hard drives have big old magnets inside. Here I've got a couple of the magnets from one of the hard drives. They are very nice, very strong rare earth magnets that hopefully, if I put them, make a mount for them for the motor will then spin the magnets and spin a little magnetic stir bar. Because magnetic stirrers cost like a couple $100 on eBay. That's the cheapest I can find any of them for. So I don't really feel like buying one. But hey, if I can make one, why not? So right now, I have a motor, one of the hard drive motors actually spun up. I have controlling it an Arduino that is sending a signal to a hobby RC speed controller for a brushless DC motor, because that's all that this is, right? All that a hard drive motor is a simple, plain old brushless DC motor. The only difference is this one has 4 pins. The 4th is an output pin of some kind, and I kind of had to swap around to see if I could figure out which one was the output pin. And that gives some kind of reporting. I'm not sure how it works, because when I hook it up to the scope or to my meter, I get weird values, and the scope signal is just absolutely nuts and all over the place. It's like 40 volts peak to peak. It looks like a sinusoid on the scope, but it has some crazy high frequency component that goes up and down like 40, 50 volts, so I don't even know what you're supposed to do. There's probably some signal conditioning you're supposed to have to do to that in order to get anything useful out of it, which I don't feel like doing right now. But then I have a potentiometer connected to the motor, connected to the Arduino, which changes the speed of the motor. So if I turn it here, you might be able to hear that, I'm not sure if you can. The motor spins up much faster. And I have it hooked up to my lab power supply here. At max speed, it pulls about 1.6 amps. And at minimum speed, it's something like 60 milliamps. So it's actually pretty good. The thing with brushless motors is that as I slow it down here, there is actually a minimum sort of speed you can drive it at before you get weird behavior, which you'll be able to see in just a second. See, it's slowing down too much. Now it's stopped, but if I speed it up just a little bit, it does this weird twitchy stuff, where it doesn't actually spin up properly and just kind of twitches around, and you have to get it up to a threshold until it'll start to spin smoothly. And then beyond that, you can lower it back down a little bit past the point where you had to bring it up to, and it will spin smoothly, but you just kind of have to get it started in a way. So, what I'm going to end up doing is, I don't have any right now, but I ordered some. I ordered some AT Tiny 13s, which will be absolutely perfect for this, because this is literally like 10 lines of code, not even. Literally just, it starts up the ESC, and the thing with hobby ESCs is that they won't boot unless they have a low value fed into them at the beginning. So the Arduino feeds a signal into here of a low throttle value. So that way when the ESC is booting up, it sees, okay, I've got that low throttle value, I'll boot up. If you have a high throttle value into an ESC when you're booting it, it will refuse to boot, because it doesn't want you, like, if you have this thing on an RC plane, you'll have your propeller on there, and if you have your throttle stick up and you boot up the ESC, you don't want the propeller to start spinning right away, otherwise it could hurt you or just take off and fly off without you wanting to. So it will refuse to start unless your throttle is down. So the Arduino just holds the throttle at the low value for about 3 seconds, and then it starts actually controlling it, and all it does is it reads an analog value from the potentiometer and scales that to an output value for the ESC. And that just uses the servo library And I'll put the code down in the description, so that way, if you're curious, you can see that. So yeah, this will soon become a magnetic stir. And what I'm going to do is I'm going to I designed a part in SolidWorks that I'll try to 3D print that will basically go over the motor shaft, and it has shaped cutouts for each of the magnets. And so hopefully I'll be able to stuff the magnets inside, glue them down to that mount, throw this thing back into the hard drive enclosure, seal it up. The hard drives are friggin' big. So I've got all this space in here that I can use for the circuitry. I can shove a little proto board with the AT-Tiny on it and have a potentiometer coming out of it. I can probably drill through the top plate that goes on top and covers it. I can probably drill through and stick my potentiometer out there or something. We'll see. We'll see what works best. But for now, that's just an update on this project, one of many. I should have an update about my Nixie tube power supply video. I plan on making a video about the design of a Nixie tube power supply and how to get 180 plus volts out of a, say, 9 or 12 volt supply for use in my Nixie tube clock. But I'm just waiting to either get circuit boards for that or be able to make my own circuit boards for that, because I'm currently not able to make boards right now. So stay tuned for that. Otherwise, thanks for watching. I'll keep you all posted on the progress of this little project. Feel free to like, subscribe, support me on Patreon if you like what I'm doing. That's all for now.